Alright folks, so we're gonna go ahead and get started on getting the configuration done. So looking at the task, we're just gonna read through all the tasks first and then deciphering exactly what they want, and at that point go ahead and initiate the configuration. So on the first task, we're gonna configure a VRF on XR1 and R2, which is on XR1 and R2. And we're going to configure VPN-A with route distinguisher 101 and route target 101. Import export. Sounds pretty good. And then assign the links connected to R1 and XR2 respectively to the VPNs. So that means these guys are my CEs and this is going to be my PE. So that's easy to understand. Configure OSPF routing for the VRF as follows. We're going to use, so it's saying the VRF word processes in R2 and RXR1. We're going to use process 100. We're going to enable it between R1 and R2, between R1 and XR2, which is that link and that link, and then XR1 and XR2, which is this link and then this link, all in area 0. Advertise the loopbacks of R1 and XR2 into OSPF area 0, and modify the link between R1 and XR2 to have an OSPF cost of 100. So that's pretty straight. I'm going to configure the BGP VPNv4 session looks like on XR1 and R2 using BGP AS100. Um, the, that's the VPNv4 session. We're going to use the loopback 0 interfaces as the source for the BGP sessions and then redistribute BGP in the VRF aware process. Pretty straightforward. Now the Sham-Link configuration looks like it's coming to play. So there's a couple caveats, and I'll explain as I go along when I'm doing the configuration of what needs to happen in order for the Sham-Link to occur and what's actually happening in the control plane of BGP as well as in OSPF to allow this to happen. Alright, and once complete, the following reachability should be achieved. R1 and XR2 should have reachability to each other's loopback. Traffic routine loopback 0 of XR1 should use the MPLS network. And if either XR1 or XR2 loses connectivity to the MPLS cloud, traffic should automatically be routed over the backwater link. Alright, I mean, this is pretty straightforward. So let's go ahead and get started. So on XR1 and XR2, I mean R2 and XR1, we're going to go ahead and configure VPN-A and put those correct route distinguishers and all that good stuff. So let's pull up our diagram and then our secure CRT session. So R2, we're going to do VRF definition VPN-A, route distinguisher 101, route target both 101, address family IPv4 unicast, do show run interface gig 1.12. Oops. Okay. And then we're going to exit that and interface gigabit 1.12. We're going to do VRF forwarding VPN-A. Take this IP address, slap this back on this interface. So that side is good. And then on XR2, we're going to do the same thing. It's not what I meant to do. Backdoor links. So on XR2, XR1, we're going to do the same thing. So we call it VRF VPN-A. Address family IPv4 unicast. Import route target 101. Export route target 101. And then we'll just go ahead and do the BGP portion because iOS XR has a different way of establishing the route distinguisher. Just so we don't forget that part. So we'll go ahead and do commit there. And then also the interface between XR1 and XR2, we need to add it to the VRF. So if we show run interface gig .1920, and you got to remember the order of operations with XR about removing and adding the IP address. So we're gonna have to remove it first, commit, VRF VPNA. Add it back and commit. Good. Looks like we're good on that. That's just giving us some messages that LDB came up when I put the original configs. Make sure that was anything serious. So, as the look of it, didn't mean to open that up. As the look of it, step one is completed. We configured the VPN and added the interfaces there. Now we're going to configure OSPF process ID 100 and enable it on the VRF, on XR1, and all this interfaces. So let's go ahead and do the CEs first because that'll be easier. So on router 1, which in this case is our PE router, we're going to enable OSPF on his link. So that is going to be gig 120. Actually, we'll just do it on the interface. Oh, let's do it on the loopback first. Interface, loopback 0, IP OSPF 100, area 0, interface gig 120, OSPF 100, area 0, and then on gig 1.112, and good to go. So on XR2, we're going to do the same thing. OSPF configuration is a little bit different on iOS XR. It's actually a little easier to me. Interface 1920, 120, and then loopback 0. And do a show here. And that should bring up some OSPF adjacencies between XR2 and R1. And I think there was another step. Let's go ahead on the CE since we're on here. Modify the link between XR1 and XR2, R1 and XR2 to have a cost of 100. So we can go ahead and make that happen now. So on interface gigabit.120, we'll call this cost 100. And then R1, Oh, no wonder. I'm like, why am I not getting interfaces up yet? So we gotta unshut that interface because we should at least have some adjacencies pop up by now. But anyway, interface gig, and we saw that come up. OSPF cost 100. So that's good. Now on the PE routers, we're gonna have to do the same thing, but we're gonna need to do the VRF aware process. So the PE for R1 is going to be R2, so we're going to enable it on there. So let's go ahead and config router OSPF 100 VRF VPNA. And just do a simple network statement. 10.1.2.0 0.0.255 area 0, and that should be done. Should get OSPF up there, and we do. And then now XR1, same thing. Router OSPF 100, and then VRF VPNA area 0, interface gig dot 1920. And then we should have OSPF up here between XR1 and XR2. So let's do a show OSPF neighbor. We don't have him up yet. Make sure R1's interfaces are up. I mean XR1 interfaces are up. And it's not. No shut. Commit. Okay, so that's about to come up here. We just built up the rest of the core here, so we would have had some issues, obviously, if the interfaces were down. Show IP interface brief, show IP route. Oh, let's see. Show OSPF neighbor. And show OSPF VRF VPN-A neighbor. Good. So we have a full neighborship between our PE and CE. Let's go back to our steps here. So we advertise XR1 and XR2's loopback in OSPF. We enable the OSPF and we use process ID. So step 2 is done. And we added link 100, OSPF cost 100 between XR2 and R1. Perfect. Now on R2 and XR1, we need to configure BGP with AS100, and then do a VPN v4 session between each other, and then we're going to redistribute between the BGP and the VRF aware OSPF process. All right, pretty straightforward. So let's go ahead and I think XR. Let's do XR first. XR is pretty easy. So we'll do config router BGP 100. Now there's going to be some things that you guys got to understand with XR. So one of the things is that the first thing you have to do is actually initiate the actual address family that you plan on using, which we're going to use VPN v4 unicast. And then we need to do a neighbor statement. So in this case, it'll be 1.1.1.1. His remote AS is going to be 100. His update source is going to be loopback 0. And then the address family we want to activate is VPN v4 unicast. And then we don't need to actually do the send community. No, I don't think we need to do that. I think that does it automatically with VPN v4 on iOS XR. And then what we need to do is under the VRF VPN-A, and then address family IPv4. Now, the reason why it's IPv4 is that because we're using VPN v4 for the exchange between the PE to PE session, you're actually initiating and activating the IPv4 routing table for the actual VRF customer, which is VPN-A at this point. So if I go back, I'll show you what I mean. I can show you through the config itself before I commit it. So router BGP 100 for the global process, we're going to activate VPN v4 address family. We're going to specify neighbor router 1, specify the loopback address, loopback as the update source, the remote AS is 100 for iBGP, and then activate the VPN v4 unicast address family for that particular neighbor. And in order for me to exchange the routes that I needed for VPN-A, for VRF VPN-A, I need to activate the address family IPv4 unicast. Now, there's another piece that's not showing here because I already added that earlier, but the route distinguisher, which enables the route target import, once the import happens, to place it into the correct VPN instance. So we'll do a commit there. And now we got to go to R2 and do the same thing. So router BGP 100, and then we're going to do no BGP default IPv4 unicast, which disables the IPv4 unicast address family. So then we're going to do neighbor 19, 19, 19, 19, remote AS 100, and then we're going to have to do the update source to make sure that loopback 0, address family VPN v4, and then neighbor 19, 19, 19, 19, activate. Perfect. So what we didn't do yet is redistribute between the VPN v4 processes. So we're going to do address family IPv4 VRF VPN-A. They're going to redistribute OSPF 100, and then within OSPF itself, router OSPF 100, we're going to redistribute BGP 100 subnets. Let's see. We got a route to 19. Okay, what the heck is going on here? Hmm. Why can't I route to router 2? Something must be missing here. Show run section router BGP. Hmm. Hmm. That should have brought my neighbor up. I don't know what the heck is going on there. Address family, VPN v4 unicast. That's good. That's good. Zone, BGP. Zone, BGP, all summary. What? Oh, wrong router. Show BGP all summary. Hmm. That is really odd. Let's see why this isn't working here. I don't understand why this is not happening right now. There must be. Interface is up. Interface is up. Interface is up. Interface is up. Oh, my dumbass. Wow, I don't know why it took me so long to figure that out. I don't know why router 1 is on my mind right now. Router BGP. That is so stupid. I feel like an idiot. Happens to all of us. So you gotta take your time. That's what I'm doing these videos. To show that everybody's human. No matter how much you know, you're always subjected to a mistake. So, just delete that. I don't know what the hell I was thinking there. No. Commit. This. And then commit. And then we should have BGP neighborship. Oh shit. Ha, I forgot I had that set to all neighbors. Thank God I didn't do anything serious. Alright, so BGP should have came up there. Perfect. So now we need to redistribute on XR1. Redistribute OSPF 100. OSPF 100. VRF VPNA. Address family IPv4 unicast. Distribute BGP 100. Commit. So we should be receiving show IP route. Show IP route. VRF VPN. Should be receiving those routes now. Let's see. Route. Receiving router 1. Show 1 router. So he's learning router 1. Is router 2 learning it? Why is he not learning 19's routes? Oh, because that 19th not being advertised. Oh, I'm sorry. I'm keep getting that mixed up. He's learning. Router 1's learning 20's routes. Sorry, guys. So router 1 has XR2's routes. So does R2 having router 2's routes. So if we look at the routing table now, right, from router 1's perspective, he's going to go over the link between himself and router 20. Now, if I was to shut that link down, just to demonstrate what this looks like, I should essentially be getting, actually, it's going to look like intra-area routes. You're going to have IA routes inside the routing table because the domain tag should match up at this case. Domain ID should match up on this case. So if I go there and then on XR2, let me do interface gig 00.120 and shut that down and commit. I should see show IP route on router 1's perspective. Well, actually, so the domain IDs are not going to match up. They're not matching up. So what I'm talking about when I say the domain ID, so BGP all summary. So if I say show BGP all, you see these routes here. So I'm going to take this particular prefix and do a show BGP all on show BGP VPNv4 unicast all, and we'll just look at that. Now, where is my domain ID? Interesting. Oh, you know what? By default, so iOS XR does not set the domain ID by default. Router 2 being an iOS XE box does. So if I do a show BGP VPNv4 unicast and I take my route for router 1, should be able to just put the prefix in there. Why is that saying subnet not in table? Unicast VRF VPN A. We'll just do it this way. So the domain ID, here it is. So the OSPF domain ID is an extended community that gets sent. So as you can see, this is the hexadecimal version, which I believe if we convert this over, this will actually be the OSPF process ID. I'm not going to do that right now, but what I am going to do to make this a little bit more sequential is I'm going to set the domain ID on the other end on the XR1 box, so that way the route's going to router 2 is also going to be set. So if I do config t router OSPF 100 and then VRF VPN A and then domain ID, I'm going to do type. What is the type? 05. So 0005, and then we're going to put the value, and then the domain ID is in hex, and that should work. So let's clear the BGP path. Clear that, and then now when I look at it, the domain ID should be set. So what's going to happen now is on our R1, what was becoming external routes should be IA routes. Perfect. And now from R2's perspective, same thing. He should have IA routes going to router 1. So let's go ahead and unshunt the link that we just disabled for those guys. 120, no shut, commit, and then our router 1 interface gig.1.120, no shut. So that should bring up back our connection, and then our IA routes go away that it needs to talk to router 20. Show IP neighbors are still coming up. So those OIA routes to 2020 should go away, and it should become a O route, but instead of the next stop being gig.12, it's going to be gig.120. So once my neighbor shit comes back up, it's just taking a little second. If I would have did point-to-point links, it would be a lot quicker, but I might end up doing that just to show you guys off of speed, because right now we're going through the whole BGP exchange or the OSPF exchange process. Yeah, it's going through the X start now, and then we just got full neighborship. So show IP route, OIA should disappear, and I should only have O routes in, which I do now. And but the problem is that the next hop is gig 120, so we're paying our service provider for all this bandwidth on this uplink into the CE routers from to the CE to the PE routers, but we're not using it due to the way the OSPF does best path collection. This is where your Sham-Links come into play. So right now we're at this part of this step here. And so what we need to do is we need to create a new loopback on router 2 with 10.10, 10.2.2.2.2, so that's 32, and same thing on router 19, another loopback address. We're going to assign these new loopbacks to the VRF VPNA, and then we're going to advertise them into BGP VPNv4. Not into the VRF aware process. And the reason for this is that you don't want the actual link to be in the link state database, because what will end up happening is that it's going to try to recurse to itself, which would end up in a route recursion loop from the link state database standpoint. So if you advertise it with BGP, once the the sham link that you're configuring, which will be in the OSPF database, those will be referencing the actual next hop of the new loopback address that is outside of the OSPF process, so it won't be a part of the link state updates. So, and we're going to configure a sham link between XR and NR2. So this is easy. This is the quick part. So sham links are very, very simple. So on XR2, let's do this. Show run section router BGP. Actually, so let's go ahead and create our new loopback address. So config t interface loopback 1 IP address 10.2.2.2 5 and then oops, I forgot one step. VRF forwarding VPNA. Lowercase v, and then we're gonna reassign that IP address. Show IP route VRF, and we can see that that new loopback address is there, loopback 1. So on an XR1 we need to do the same thing. Commit. Perfect. So the next step is that we need to advertise the new loopbacks within the VPNv4 BGP process. What that means is that we're going to advertise the route in the actual IPv4 table of the VRF. So what we're going to do is go to router BGP 100 on iOS XR, address family IPv4 VRF VPNA, and then we're going to advertise the network of 10.2.2.2 with the mask of 255.255.255. Right? Perfect. Now, same thing, we're going to go on XR1, do the same thing. So we're going to go to router BGP 100, VRF VPNA, address family IPv4 unicast, and we're going to do the network 19.19.19/32. Perfect. So XR1 should be learning that new loopback address as an external route. Same with XR2. Show route VRF VPNA. I'm sorry, XR1. Show route VRF VPNA. And he's learning it via BGP on the other side. He hasn't got to the other route yet via BGP. Why is that? Did I not redistribute BGP in the OSPF? I should have. Show run section router OSPF. Oh, there it is. Should have came in now. Yep, we got it now. And he should learn that too. Yep, through an external route here. So he is learning it via BGP. Oh, in his routing table, and then he should be learning it as an external route here, as he is on a 10.2.2.2. So those two routes are being learned for Type 5 LSAs from the OSPF perspective on both PCE routers, right? Perfect. So the next thing we need to do on the PE routers is under the VRF aware process, we need to configure the sham link, but the peering of the tunnels are going to be this 10.19.19.19 and 10.2.2 as the source and destination. on the respective router processors. So OSPF 100, and we're going to do area 0 sham link, and then the source address, which is going to be our side, and then the destination is 10.19.19.19. Good. And then in XR1, same thing. We're going to do router OSPF 1. Oh, and actually, I wanted to show you guys on the OSPF database. So show OSPF, show IP OSPF database. Now, remember, as I said, that you're going to have the routes that are going to be type 1 routes are going to be the connected interfaces in 19 and 20. So he's not really advertising anything. Um, he's getting 20 because of the link that is up between between R1 and XR2 right there. That's why we're getting a type 1 LSA there. So if we were to disable that, this would not be there, and yeah, this should not be there as well, because this is flooding going through XR2 from XR1's interface. So this is link being in OSPF. That 1.2 is there, 1919. So you're going to look at the 1.2, which is this link here. The link router ID of 19 is here, and the router ID of 20 is here, and that's because this is all flooding from a type 1 LSA perspective. Now, that's going to change here once we enable the OSPF sham link on the PE routers. So I'm going to go to VRF VPNA, go to area 0, and we're going to do sham link. The source IP is 10.19.19.19, and then the destination is 10.2.2.2. Required config. Oh, I used the wrong OSPF process. I used the exact same wrong OSPF process. So now, OSPF 100, VPN A, area 0, sham link 10.19.19.19, 10.2.2.2. Perfect. And then we should see a sham link come up between R2 and XR2. Show IP route. So show IP OSPF VRF. Show IP OSPF sham links. Is that up yet? It's down. Why is it down? So that should have came up. Alright. On router OSPF 100. Why didn't that come up? I'm in the VPN. Area 0. Show IPv4 interface. IPv4 VRF all interface. Brief. Let's see. I'm not learning 10.2.2.2. Let's see why. Why am I not learning 10.2.2.2? Hmm. What the heck is going on here? Did my router reset or something? Oh, looks like we have a problem here. What's going on here? To router 6, he lost his adjacency with router 19. Oh, I think I know exactly what I did. Because I deleted the OSPF process, I just broke my network unknowingly. Because router OSPF 1 is actually being used for the internal core network. So when I did that, I actually blew out the actual OSPF configuration. So actually, I need to bring that back here. Come here. That was so stupid. All right. That should have came up already. It's gonna come up here in a second because I was like, I knew I just saw the route in his routing table earlier. So when that's set, it gets reestablished. OSPF neighbor, we're good there. Show IP route VRF. We should be learning. All right, so now the virtual link just came up for sure. So that's my BGP, and my virtual link should be coming up here shortly. Okay, now it's up. Good. So our sham link OSPF virtual link just came up here. So you can see here. So now if I look at my routing table now, router one's perspective, show IP route, it's still showing. Hmm, kept the domain ID the same. Did it change on me? Oh no, I'm tripping. Now I'm looking for the inter-area routes. So those disappeared. As you noticed before, so now we're getting intra-area routes that are coming over the VPN MPLS link here. So if I look at the show IP OSPF database, I should see now only we should see now the router the link state ID is coming in, but now this DNA is actually being flooded for the virtual link because just I mean from the sham link because just like the virtual links, the do not age bit gets set on the routes that originated over the virtual link, just for table routed table stability, so you know so you won't be reflooding out to relearn it. So essentially, router 19 now, which is from router one's perspective, is sending that do not age bit. Because that tunnel that's sitting here, he's looking like he's a part of the OSPF area that's flooding over that serial, that sham link, which is now triggering instead of it being a Type 3 LSA because the domain ID match, it's going to now look like a Type 1 LSA because you're actually flooding the domain, the Type 1 router LSA, all the way across the MPLS, what they call the super backbone. Um, it's one of my favorite topics. I like doing labs on it. It's just really cool. And then understanding OSPF route manipulations, I think, is one of the hardest things as far as the L3 VPNs is concerned from PE to CE routing protocols that you got to keep in mind on how to actually do this correctly. But what we're going to verify now is that another part of the task was to make sure that if the link goes down, if connectivity between R1 and R2 goes down within the MPLS cloud, traffic should automatically be rerouted over the backdoor link, which in this case, the backdoor link is this gig 120, which it will, and we can go ahead and try that now. So on R1 and R2, I'll just shut down the link between them, and then we're gonna shut that down. And so show IP route, and we should see routes automatically go over to gig 120 as you see here. So traffic is there. I should be able to still ping 20, 20, 20, 20. Source move back 0, and that's good to go. And then go back to interface gig dot 120, 110. I mean 112. Show IP route, and once the neighborship reestablishes, we should be going back over. Yeah, neighborship's back up, and we should be going back over dot 112. It's still going through its learn process, and now it is. And if we do that, mm, no, that was weird. I don't know why my trace route's not working. That is really odd. Oh, if I would add another 20 on there. Yep. So now you can see that it's actually taking the MPLS L3 VPN path over using the Sham-Link. So that's L3 VPNs on Sham-Links, one of my favorite topics. If you guys have any questions, let me know, and I'll be happy to answer. All right, later.